Hi there, welcome back to Stationeers. Okay, so we are back on our kind of creative test world thingamajig because I've been working on something else and I just thought I'd kind of show you what I've been doing just for the hell of it, really. So, the last time we were here, I went through my auto ingot requesting and kind of auto sort of crafting based on a selection on the stacker. And it all works really well. Obviously, we've tested this. We're using it on Europa, and we know it works. So because it's running out of ingots, I ain't got no copper, so it's requesting it, and it's just doing its thing. And I can obviously set this to, if I set this to 0, set it to 1. If I print one of them, we know that it'll only print one of them. And job done, really. That obviously works perfect. Excuse me. I want to go a step further, or I wanted to go a step further. And what I wanted to do was build something that would auto craft for me. Because there are certain items in the game that you're always going to need. Such as you're always going to need cable, you're probably always going to need frames, pipes, that kind of thing. So I wanted to know, could I build a system which would keep a stock of whatever items I want available to me? And I need it to be dynamic. I don't want to have to set the types of items it will produce. I want it to know what I want and make sure that I've always got some of them. And I've done it. So let me fly over here with my really slow backpack. Excuse me. And I will show you what I've done. Now, I have no doubt people have probably built something similar or better or whatever, but this is my take on an auto crafting setup, and hopefully you like it. So, the idea here is I have a locker of whatever items I want. So I've gone for like one of each of the sheets, a couple of stacks of the frames, the different types of wall, pipes, I've got some active vents which we'll go through later, coils and heavy cable coils. Oh, some lights as well. I've picked these items just at random, but anything that can stack would work on this system. It doesn't matter. What this system does is it is checking all of the slots in that locker, and if anything is not the max stack size, it will produce the difference, and it will restack it for me. So, as an example, let's say I take some cables. I'm just going to go and build something in my base and just place some cables. And now have a stack of 64. I'm going to go put those back in my locker. The system knows that those cables, some cables have been used. I've got 44 and the max stack size is 50. So the electronics printer is now printing me 6. Because that's how many I'm missing. My Larry grabs the cables that I have in the locker, stacks them up to the 50 for me, and then places them back in the locker where it found them. So it isn't reorganizing my locker. However I have this set is how this will stay. So as an example, let me get some pipes. And we'll just place one so we're not waiting all day. I got this from here, but I'm going to place it here. The system has noticed that the pipes are obviously lacking. So our pipe bender is now printing. And it's restacking. Grab in the complete stack. And we'll put that back where it found it. So it allows you to organize your locker however you want. And nothing is predetermined in here. So, for example, obviously I've got the active vent, but let's go for something else that I haven't already got. So what can we make that stacks? Let's go for, I don't know, a pump. Pump stack into 5s, I believe, right? I might be wrong, but let's spawn in some pumps. So we've got that. Yeah, stack of 5. But let's get rid of a couple of those. Out to Europa you go. Let's put 3 pumps in. I'm going to stick them there. The system knows, oh, hang on a second, you haven't got a full stack of pumps. And the pipe bender starts producing. And the whole system just works. It doesn't matter. It also allows you to, I could store anything in this locker. So I could, if I wanted to, I could put a tool in there. It's not going to break anything. So if I put my crowbar in, hang on. Yep, so if I put my crowbar there, it's not going to stop. It doesn't care. Like, that crowbar is fine because you can't stack crowbars. But what happens if I've got something that these printers can't print? Well, let's go for the rocket gas tank. So as we know, most of the rocket components can only be produced in the rocket manufactory. So what's going to happen when I put this in? It's going to identify the rocket, but it's going to cycle through the printers, realize that none of them could do it, and just move on. And it doesn't stop the code from functioning. Obviously, it slows it down a little bit because it's constantly checking. But in theory, if every single item in there needed topping up and I put that in, the system would just work through it. That would not stop it. I've only gone for the 3 basic printers because there's no point in implementing the tool manufactory, because almost everything apart from maybe flags you can't stack, so I don't see the point in having the system do that. And the rocket manufactory, I mean, you don't really all need a stack of everything. If you wanted to, you could implement that printer and change one of the pins and then slightly manipulate the code, but I don't see the point. I personally would not have a use for that, so I just haven't bothered with that. But that's basically how this works. It's not going to complain if I take something out. It doesn't care. It only cares if there's something in there and it's not a full stack. This will also work on different size lockers. It doesn't have to be the big one. You could do, well, anything from the locker kit really. Or anything with a slot this will work on. We could do it on this locker, the locker small, the shelves, the mediums, whatever. It doesn't matter. It will work on all of them. If you wanted to, you could have an import chute and just hold one item and it would still work. It is absolutely, it is perfectly dynamic. It doesn't care. And that's exactly what I wanted. You could code it if you wanted to, so that slot 1 should always be cable and slot 2 should always be something else and yada 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 yada. But I don't want that. I'm not a tidy person. I mean, there'll come a time when chances are my lockers will look something like this. And it will not break this setup. This is absolutely... It doesn't care. If I put 1 in there, obviously rather than just the 19, it will craft the 19 required. And it knows the... Well, it doesn't know the printer, which one's required, but I'll go through that in a second. And what you'll probably notice as well is, well, cables can be printed in both the autolathe and the electronics printer. So how do you know it's not going to do that? It's working in order. So the item that is required is always checked on the electronics printer first. If it's a valid recipe, it will print. If not, it will then pass that job to the pipe bender and then check, is it a valid recipe here? If not, then it'll go to the autolathe. So that's why the autolathe is last. How out here in the world, it doesn't matter. But in the coding, which you'll see, the autolathe needs to be last. The pipe bender and the electronics printer, you could rotate these. This bit doesn't really matter. But it's like cables can be printed in this and this, but I want them to be printed in this one first. I'm not sure what else there is like that. Oh, chutes. So chutes can be printed in both the pipe bender and the autolathe, but we always want them to be printed from the pipe bender first because it's quicker. And then before we get onto the code and the build and whatever, nothing is coded on the import slots. The import slots, doesn't do anything, it doesn't care. So you could combine this with my ingot requesting code that I set up before. And that would keep these printers stocked. And yeah, in theory, this would just work. Obviously, depending on what you're storing, so like the insulated pipes, you can obviously need a source of steel. Whether you automate that or you do it manually, that's another question. But yeah, that's basically what it does. So whilst we're just kind of going to go through stuff, let's keep it busy. Print me some cables. And look how quickly that is. So we'll go through the build and then we'll kind of go through that. we've got our 3 printers. The order doesn't matter here, like I said, as long as the autolave is coded last, but we'll go through that. The output of all 3 printers feed into a single chute system. So the autolave is going into a junction, the electronics printer is going into a junction. This chute feeds directly this way into a stacker. The stacker is dynamically changing its setting based on the amount of items we're printing. Or, sorry, based on the maximum stack size. So with cable, that's why it says 50. If I was printing pipe, the code is setting that to 20. That stacker feeds into an export slot. And this is where our Larry will pick up from. And then on this side, we have the import slot, which feeds into the chute network before the stacker. Because what happens is it's reading the item that's needed. So you can see cable. It knows the max size, stack size is 50. So it sets that to 50. And as we know, when a stacker obtains this stack, the amount it wants, it automatically ejects. So it's going to print 49. He goes and gets the other 1. That's going through the chute, gets combined with the stacker, forces that through, makes it available. And then he just very nicely puts it back in our locker. The actual Larry itself doesn't really matter the station numbers or anything. I've done it really small, but you could span this further if you wanted to. It makes no difference. I've got station 0 above the locker, station 1 above my import bin, station 3 above my export bin. Doesn't matter because you can set that in the code. I'm just showing you that that's what I've done. Also, what you'll notice is if we look at this dial, it's almost like it's missing some numbers, but it isn't. The code is checking this entire locker every in-game tick. So every half a second, it's checked every single slot in there. Certain devices such as the Larry and the console can't keep up with that kind of speed. So it makes it look like it's not checking them all, but it is. So as you can see, look, it looks like it didn't check slot 1. But eventually it will change. So at the moment we keep seeing slot 3, but it will slightly change once it catches up. There you go, look, now we're on 4. But I can very easily take some out of here. And that's not slowed down in the slightest. Look, there we go. We've got a cable. Not an issue. And that has just been done by not having any yields on the checking state of the locker. So, the code. Out here, we've currently got the current quantity. So, of the whatever item it's checking, this is how many we've got. The max quantity is exactly that. It's the max quantity of that item. So cables is always 50, frames is 30, pipes is 20. But that's just pulling that directly from the item. The hash display is connected to the housing. So I'm writing the hash of the item it's checking to that, and then that is just being read by that console. And then the pins, I've got the electronics printer on D0, pipe bender on D1, autolave on D2. These two don't matter the order, but the autolave has to be on D2 for this to work. Or for this to work well. If I put all the autolave on D0, it would be fine. It just means that the cables and chutes would be printed in the autolave, and it would just make the whole thing a little bit slower. So that's why I've done it like that. And then D3 is the Larry, D4 is the import bin, D5 is the export bin. And that's it. Into the code. So it's not as complex as it looks, in all honesty. It just took a little bit of tinkering to get timings correct. But I've tested it and it's not failing at all. So we're aliasing our printer to D0. You'll notice that we're not aliasing all 3 printers. That's because during the code we dynamically change the printer that we're pointing to. So we're only aliasing one of them to start with. There's the Larry, the import, the export bin. Because we're running out of pins, our stacker, we are referring to that via the ID. So we're defining that. Same with the LEDs, so the current quantity and the max quantity. Both optional. And I've put a note here, like, if you don't want to do this, then you could remove this line and also remove line 28. And then your code won't fail. I'm just aliasing a few registers, just so I don't reuse them or override them. The slot index is used to tell the Larry which slot in the locker to look at. So to start with, we set that to 0. when we're initializing the code, and then throughout the code we'll change that number. Here you have to just set the station. So obviously 0 is where our locker is, 1's our drop off, which is the import bin, and 3 is the export bin. We're just defining another register. To be fair, I could use alias there. It doesn't matter. I don't know why I've done it as define, but never mind. And then we're going to move that to 29. So this number is how many slots you have in the locker. Now the large locker has 30 slots. Okay, you've got 6 rows of 5. But the first slot is index 0. So whenever you're telling it how many slots, you always minus 1 from that, because the first one is 0, which makes the last one in this 29. So that is why in the code, I've got this set to 29. And I've put a note there kind of saying minus 1 from how many slots you've got. And then before we start anything, we tell the Larry to go to the locker. We also set it to 0 because we've obviously moved slot index to 0 here. So we're doing that. We're turning all the printers off, D0, D1, D2. I haven't aliased them, which is why I'm using D0, D1, D2. Obviously, we could have wanted to save to the printer, but just for simplification, I think is the word, we'll just do D0, 1, 2, and 1. Wait, 0, 2, 1. Those numbers. We then, obviously, the stacker, because we haven't got a pin, we're save devicing to the stacker, the on is off. So we're turning it off. And then we start our code. The first thing we're doing is we're making sure the Larry is idle. We're doing that because if the rail was much longer, when I initialize the code, the Larry might still be traveling back here. So we want to make sure that is in place before we start anything. So if it's not idle, it'll just keep going back to this line, and it'll just stay here until that Larry is ready. We then, from the Larry, slot 255, load the prefab hash. So on the Larry, and most people will know this, but if you don't, so it doesn't really matter, they're all the same, but on the cargo Larry, which is the one we're using, it has a proxy slot, and this slot is the in-world device or item or whatever it's currently looking at. So in this current instance, slot 255 is the locker. If I have it over here, slot 255 would be the import bin. When it's here, slot 255 would be the export bin. That's how that works. So you could do slot reading like any other device from slot 255, but you can read from the locker. And then the Larry has a setting on it called target slot index. So that is the slot within the device it's trying to interact with. So in slot 255, and then slot index 0 would be this one. Slot index, what's that? 9, 10, 11, 12 would be this one. So we obviously load the hash. We save that to the DB, which is being used by the console. We then load the quantity, so how many we've got in that stack, and that gets stored into a register. And we save that to the LED, just that's the line that you would remove if you didn't want it. And then we also load the max quantity, and we save that to another LED. To get the max quantity of an item, find that item, and it is this, the stack size. That is the max quantity you can have. So I don't know if the autolave has it. Let's have a quick look. The kit autolave, yeah, look, stack size of 1. So most kits or items will have this. Don't get confused though if you search for cable, and let's say you click on this one. Obviously there's no stack size. That's because that is the cable when built in the world. Obviously they don't have a stack size because it exists. It doesn't exist as a pile of them. You need to go to the cable coil, and that is where you'll find the stack size. But we obtain that information, and then we check, is the current quantity, so the amount that we've got, less than the max quantity? If it is, we jump to printer loop. If it isn't, we jump to next slot, and we'll go through that shortly. So the printer loop, what we do, this is pretty much the only place where you're going to find the yields as it's turning on and off the printers. But first, it aliases printer to D0, which we know is the electronics printer. And then we jump to check printer. What this does is turns the printer on, saves the recipe hash to the item hash we retrieved from the locker. So tells the printer, okay, I want you to change your setting to this. So if I was in here, obviously me doing this is the recipe hash. This is what is currently configured to be printed. So we tell the printer to do that. We then give it half a tick, and then we load from the printer. So we're giving it enough time for that to write, and then we load from it. And then we check, does the recipe hash on the printer match the item hash that we took from the locker? And the reason I'm doing that is because if you try and write a recipe to this printer that doesn't exist in the printer, it won't change. So we don't have sheets in here. You can't print iron, steel, plastic or glass sheets in here. If I try to write that recipe hash to this printer, it won't do anything. It doesn't error, it just doesn't do anything. So whatever was previously selected, that is checked against what we want, and if it isn't the same, then it goes, okay, you're no good to me, move on to the next printer. Do that. It'll do the same check. Because it's a sheet, you can't make sheets in the pipe bender, and it'll know that because when it tries to write to it, it won't change, so it'll turn that off and it'll go to the auto leave. When in here, it'll go, oh, hang on a second, I do have sheets in here. Obviously I could be scrolling all day, but I'm not going to do that. And it goes, right, we can go from there. And that is why we have the auto lathe last, because there's certain items that can be made in both the electronics printer and the auto lathe, and also in the pipe bender and the auto lathe. So you always want to use one of these ones first because they're quicker and more efficient on power. But that's what this is doing. So once it finds the recipe, once it finds a printer that can accept the recipe hash, it will jump to start print. Otherwise, it turns it off and then jumps to RA. And remember that RA we got from up here. So then it moves to the next printer, so on and so forth, and blah 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 blah. If it gets to start print, so obviously we found a printer that can accept it, then we want to obviously start the printing of that. So what we do is we find out how many more we need to get our stack to the full stack size. So if we need 50, but we've got 40, it will find the difference of 10. We then clear the memory of the printer, so as far as it's concerned, it hasn't printed anything. We save the amount that we want, so the 10 will get saved to the stacker setting, and we turn the stacker on ready, and then we activate the printer. So remember, at this point, we have already set the recipe hash on the appropriate printer. All we got, it doesn't matter what printer it is, we're referring to it as printer because we've aliased each printer as we go through the checks. And then once we've activated it, that starts the print. And then here, we kind of get stuck in the code until the export count is less than... no, sorry. So we load how many it's printed. And then here we check, is the amount we've printed less than the difference that we need, so 10. If it's printed 1, it goes, yes, it is less. Go back a line. So it goes back to here. And it will do that loop constantly until the export count equals, well, if we're printing 10, the export count equals 10. It gets to here and goes, oh, it equals 10. Let's not branch backward, let's go forwards. So we're going to turn the printer off. And then we're going to clear the memory of the printer ready for the next time. In theory, I don't need both of these. I've just put them in there for safety, really. But I could probably get away with removing one of these. To be honest, I'd probably remove this one. But I've left it in because it is what it is. Now for Larry. So at this point, the Larry is still above the locker. And it is still looking at the slots that it originally looked at. So let's say this was cables. It checked the cable. It figured out we've got 40. We've got a max size of 50. It's still over there. We activate the Larry because at this point there's nothing in its hand. So it will pick up whatever is in that slot. We've got an idle check that's referenced throughout the code. And that idle check, all it's doing is it's checking that the Larry is idle. If it isn't, it gets stuck in this loop until it is idle. At which point it jumps back to RA, which is referenced obviously with the gel. So whenever you see this, that's all it's doing. It's waiting for the Larry to basically stop moving. once the Larry is picked up its item, we save the target slot index as 0. So the reason we're doing this is because if you are dealing with a slot in here that is above 0, and then the other devices that you want to interact with only have a single slot, it cannot place or pull out of it. So if I set this to a slot index of 10 and then try and get it to put something in there, it won't, because it's looking for a slot index of 10 and it doesn't have one. So what you'll notice in the code is when I'm handling the locker, so down here, we reapply the slot index to the Larry. When we're interacting with anything else, we move the slot index to 0. So that way we're not going to have any issues. So we set it to 0, and then we tell it to go to the item drop off. We wait for it to be idle again. Once it's idle, that means it must have got to the drop off. So we activate it. Then we wait for it to be idle again. And this is where it's going to put into the import bin. So once it's idle, that means it's placed whatever it had. So then we just save to the import bin a close. So all that does, and I can't do it because the lever's in the locker, but basically that kind of simulates us pressing the lever, which shoves the thing down, and then it opens itself automatically. We don't have to worry about reopening it. We then tell it to go to the item pickup. So that's the export bin. And again, wait for it to be idle. And then here, we're just checking that the export bin is open. Because for a time, so what's our stacker set to? So it's set to 50. I just turn this on for a second, and I grab the sheets. Oh, I can't do it because, yeah. But basically, there'll be a time when the Larry drops the item into the import bin. That item has got to travel down the chute into the stacker. The stacker's got to eject it, and it's got to appear in here. So that time is probably more than an in-game tick. This export bin remains closed until it has an item to be dispensed or to be picked up. So what we're doing is we're checking that export bin is open. Because if it's open, there's something there. If it isn't, then the item that we've put in hasn't reached it yet. So at that point, we're waiting. Once the export bin is open, it's safe to turn the stacker off because we've obviously retrieved our item. Then we're going to activate the Larry to go and pick it up. And again, we're going to wait for it to be idle. And then we're going to tell the Larry to go back to the locker location. And then we are going to reapply the slot index. So whatever the slot index was at the start is what we're going to save it back to. Wait for it to be idle. Once it's idle, it's going to be above the locker, so we're going to activate it. And because we put the slot index back, that is where it's going to place it. We then wait for it to be idle, and at that point, we've done. We then need to change the slot. So assuming all of that did slot index 0, we now want it to go to slot index 1. To change that, all we're doing is checking if the slot index is already 29. Now actually I've made a mistake here. That says 29, but actually what that should say is locker total slots. Let me just put that in because we want that to be dynamic. There we go, my bad. So if the slot index is equal to whatever we've set, branch 3 lines. 1, 2, 3. So it'll skip these two and it'll go here, which moves the index to 0. So we're starting again. If it isn't equal to 29, so if it's any other number, we go down and we add 1 to it. So if it was 0, we're going to add 1. It's going to become 1. It'll then go to here and it will jump relative 2 lines. So we'll basically go down to this. So all of this code will eventually always land at this line here. At which point we just save to the Larry the target slot index of the new slot index. Either 0 or whatever the number is. Jump back to start. And then from there, we start again. So we make sure the Larry is idle. And then we go through it. And that is pretty much it. Now, I think that is pretty simple bit of code for what is otherwise a pretty nice quality of a life to have. Because I hate having to go for some cables that I haven't got. Like, oh, I'm going to have to go and print these. Oh, I need to go and do X, Y, and Z while it's doing it because I can't do anything about the cables. I've always got them to hand. Obviously, this would be tiny, so you set this up however you want to. And you'll see that I've got two of like the important stuff. So I've got 2 stacks of cable, 2 stacks of heavy cable, because there'll be times when I'm going like, okay, I'm going to need a lot of cable, take both of them. And then all I have to do is make sure that I put at least 1 cable back into either a single or multiple slots. I mean, if I wanted to, there is nothing stopping me. You know what, just trick these on the floor. If I wanted to, I could have 5 slots of cables. So let's just do that. That system will now make sure that all those slots get filled. Obviously, it's going to take time. I've got to wait for the printer to print. But do whatever the hell you want. This system is completely dynamic. It's, when I've made it, I've tried to make it to suit the person wanting it. Like I said at the start, I could have, if I wanted to, I could have used the stack. I could have programmed into the stack of the housing, like, oh, I always want 150 cables in there, or I always want 100 sheets, or I always want 60 pipes, and I could have hard-coded that. But not everyone wants pipes on demand. Some people might want shit tons of cables. Other people might want active vent, passive vent. You could do pumps, analyzers, anything, and this system will just work and keep you, well, basically keep you stocked. Like I said, I haven't built any ingot requesting or reagent kind of checking into this system, because the other system I've done, my ingot requesting system, is more than sufficient for this. Nothing is on the input, so you could just plug that system into this and yeah, jobs are good and it will just work. But by itself, this is also a functioning system. It doesn't require anything else. If you want to just keep it like this and stock these up with ingots, you be my guest. Absolutely fine. If it runs out of an ingot, all it will do is it'll just pause. It'll just wait where it is. So if this runs out of copper, then the whole system is waiting for there to be an export count on this printer. So just feed it some copper, set it off again, and the code will pick up where it left off. Obviously, if you eject your ingots from this, then that's going to mess up your export count, at which point it might be worth just resetting the system. So pull your chip out, turn it off, turn it back on again. Job done. You could also put safeties in here as well. So there's parts of the code where I could, if I wanted to, check that the ARM slot has something in it before proceeding, but I haven't done that. I've gone for the most lightweight approach I can think of to get the job done. 100% people will have a better idea. 1000% people will improve on it. But for me, I'm happy with this as a solution to an otherwise could be annoying issue of just running out of stuff. So I will definitely be using this going forward, if I remember how to set it up. So what I'm going to do is, straight after this video, I'm going to put this onto the workshop, and it's just there for you if you want to use it. Feel free. And yeah, if you like this or you have any ideas of improvements, let me know in the comments. I'd be interested to see what other people can come up with. There's always more than one way to come up with a solution. So yeah, share. So bit of a shorter video, but you know, just kind of showcasing my autocrafting setup. And yeah, we'll leave it there. So thanks for watching. Until next time, take care, and I will see you then. Bye.